Okay, today we're going to be talking about rational numbers. The real number system consists of rational and irrational numbers. Rational numbers can be expressed in fractional form. The decimal form of the number either terminates or repeats. Counting numbers, whole numbers, integers, and non-integers are all rational numbers. The counting numbers consist of the natural numbers. These are the numbers that you first learned about, and it's when you started counting. You started on 1, counting objects, and so on. Then, as you grew older, you learned about the whole numbers, and it consisted of the counting numbers and 0. Notice that in the set, the whole numbers are all positive, and so this would be the set of all whole numbers right there. For the integers, they consist of the whole numbers and their opposite. This ... on either side lets you know that these numbers go on and on infinitely long in either direction. Basically, integers are the numbers we see on the number line. The rational numbers consist of fractions that can be written as terminating or repeating decimals. A terminating decimal comes to a complete stop. It is basically when you're changing a fraction to a decimal and you divide, you would get a remainder of 0. 0.6 or 6/10 is an example of a terminating decimal. It just ends. However, a repeating decimal continues with the same digit or block of digits forever and ever. And if you divided and 5.25 repeating, 5 and 25/100ths repeating, would be more like 5.25252525 and so forth. You'll start to recognize that pattern, and then you can use the Repeten bar to show the repeating digit or set of digits in your notation. So all of these on this slide are examples of rational numbers. Notice that we do have whole numbers and integers that are rational, but these are all the numbers on the number line in between and can be written as fractions. This visual gives you a real good picture of the real number system. We have rationals on the left and irrationals on the right. You'll learn more about those in 8th grade. The irrational numbers consist of, say, pi, because it does not repeat or terminate. The numbers such as the radical square root of 2 and things like that, that when you reduce them and simplify them down, they do not fit the definition of a rational number, which basically is any number that can be written as a fraction. It could be put into decimal form, either terminating or repeating. So on the left, where the rational number, integer, whole number picture is, notice that the whole numbers are on the very innermost part of the circle. Whole numbers, all whole numbers are integers. Whole numbers are on the number line. They are the positive side of 0, including 0. So examples would be the number 1, the number 5, 0, so on. The integers consist of all of the whole numbers and their opposites. So we've got a -6, we've got a -20. Now notice that it's not necessary in the dark blue section for me to include any positive numbers, because those are included all in that whole number inner circle that is also part of the integer set. And then finally, we've got the rational numbers that include integers, that include whole numbers, but it also is everything in between on the number line. So you could have 2.5 or a -1/2 or any other form of a decimal that either terminates or repeats. But also note, integers and whole numbers are rational numbers. So let's give this a try. In this next slide, example 1, we are going to classify or tell whether each number is included in each of the following number groups or sets. We want to know if they're rational, integer, or whole, or all of the above. So looking at the first one, a -23.75, it is a decimal, it is a terminating decimal. Even though it's negative, it's not an integer, because it is the integer's definition is whole numbers and their opposites, and it is not a whole number. So we would say that that is simply a rational number. Okay, the number 4 hopefully is recognized as a whole number, and because of that is also an integer, and all whole numbers and integers are rational, so it is a member of all 3 sets of numbers. 5/9 is a fraction. By definition, all rational numbers can be written as a fraction. However, fractions have a decimal form, and since it's not improper or does not divide into a whole number, it is only a rational number. When we divide this out, it will be a decimal that will either terminate or repeat. And -15. -15 is not a whole number because it's negative. It is the opposite of a whole number. It's opposite of 15, so it belongs to the integer group, but not to the whole group. And rational. Okay. If you need to watch the video again, or take it a little bit slower or rewind to the spot that you need help with, feel free to do so until you can complete all of the numbers in example 1 and definitely be able to categorize them and understand why they're in each category so that you'll be able to successfully complete this for your homework.